Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology and Autonomous Institution Coimbatore. In this YouTube video, I am going to discuss about 23 ECET 212 Linear Control System subject under the topic Open Loop and Closed Loop System. So based on my previous YouTube video, you have the knowledge about what is meant by control system and how a open loop control system is differentiated by the closed loop control system. Now we will see in detail. Control system. When a number of elements are combined together to form a system to produce desired output, then the system is referred to as a control system. System controls the output. Each element connected to the system has its own effect on the output. For example, if you take this as our model, the input is given to R resistor, L inductor and capacitor C, and the current is flowing from each component. So whenever this current is flowing from each component in this circuit will give some of its own characteristics. For example, resistor will resist the input current, the inductor will convert this into mutual inductance value, then the capacitor will have the power of changing the capacitance of this input signal. So definition and features of control system. A control system is a system of device or set of devices that manages, commands, directs or regulates the behavior of other devices or systems to achieve desired results. System which control other systems. Human civilization, modernized demand for automation requires control of devices. Features of control system. Mathematical relationship between input and output of the system can be represented by a linear proportionality. The system is called linear control system. If it's related by some non-linear relation, then the system is called non-linear control system. That is, whenever the control system is easily written on a mathematical model, then it is called the linear control system. Sometimes the control system which cannot be applicable for a non-linear relationship, then it is called a non-linear control system. The requirements of good control system: accuracy, sensitivity, noise, stability, bandwidth, speed and oscillations. So depend upon this, if all the criteria are satisfied, then we can say the taken control system is the good one. First we see accuracy, measurement, tolerance of the system, limits of the error made in normal operating conditions. It is improved by using feedback elements and error detector. That is, accuracy is the first important criteria which should satisfy any control system in a good point. More the accuracy, more the good benefit of control system. Sensitivity, parameter changes, surrounding conditions, internal disturbance or any other parameters in terms of sensitivity. Any control system should be insensitive to such parameter but sensitive to input signals only. Noise, an undesired input signal. For any system, the noise is the unwanted that we can eliminate whatever the ratio we want. Stability, for the bounded input signal, the output must be bounded. If the input is 0, then the output must be 0. That is called the stable system. Bandwidth, an operating frequency ranges decided. It should be as large as possible for the frequency response of good control system. Speed, it is the time taken by the control system to achieve its stable output. The transient period for such system is very small. Oscillations, a small number of oscillation or constant oscillation on output tend to indicate the system to be stable. So types of control system. In previous slide we see open loop control system and a closed loop control system. Now it is the other name called automatic control system and manual control system. For example, if you see inside the car, in old Maruti car and generation, the manual transmission is used. Now if you taken the latest car, the automatic transmission is applicable. The temperature of a room increases as long as the power supply switch is kept on. Heating element produces heat power supply on, and final room temperature doesn't have any control over the input power supply of the system. This is the example of open loop control system. The heating element of the system function, that is equal to error of the system equal to actual temperature minus desired temperature. This error signal is fed back to the system to control the input, as the input to the output path and error feedback path create a closed loop. So this is the example of closed loop control system. Now we can see detail in how open loop control system is working. So in this YouTube video, I discussed what is control system and what are the various elements of control system.